Hello team, by this moment in our course I assume that you already learned Jira API in the previous lessons. So now it is time to start implementation of Jira API integration with our web application that automates project management operations. Namely, we're going to build integration between Jira API, GPT API, Slack, and our web application. I'm going to teach you how to connect Jira as a separate data source that you will use for gathering required context. In scope of this lesson, we will not post data to the Jira data source. In other words, we will not create items there. We will just read from Jira. How to post data to Jira data source, we're going to learn in the next lessons. I will show you on real examples how you can implement function calling feature to fetch required data items to add them to the context. By the end of this lesson, you are supposed to have completely functional and already useful application, and I'm going to show you the demo of how you can use it. As we will make an overview of the source code, line by line, I will make an architecture overview and will share with you the best practices of web development. Let's start our lesson. If you follow the course and you don't skip any lessons, then you have enough theoretical knowledge and practical skills to follow the live demo session that I'm going to hold in this lesson. Today we are going to have a lesson full of practical examples, and I will walk you through my solution line by line, explaining you how we achieved this result. Let's start from review of the result that we are going to achieve by the end of this lesson. I believe that in this way you are going to be motivated to watch the lesson till the end, and you will have a clear picture in the head of what we are going to achieve when we will get to the source code. Watching source code and keeping in the head the image of the end result will help you to stay focused, concentrated, and will help you to get answers to your questions. I opened Slack. In our imaginary case, this is our team chat where we collaborate. Imagine that during the conversation, any participant of the chat would like to clarify more details about current progress of work, remaining items to do, or other information related to the product that we work on. With Jira integration and GPT analysis capabilities, we can get the answers that we expect to get. I believe that you watched lesson about function calling feature in ChatGPT, because it is important to understand the lesson examples. I will just remind you quickly what it is about. We give to the GPT the array of functions descriptions to tell it what functions we have on our end, and which functions we can call in case it would be needed. And GPT makes decision based on the context whether some function should be called and result of the function should be provided as an input. So basically, in our today's demo, GPT will understand that we need to make a call to Jira API in order to fetch some additional information, and after providing requested information from Jira, GPT will provide an answer. So, imagine that in our work chat during the conversation somebody needs to get additional information in order to make data-driven decision. And to save some time on opening a Jira project, building a query, analyzing the data, I can simply ask my bot to provide me with some information. For example, I ask general question, something like this. GPT, how many work items do we have in Jira? And I receive the response that in Jira project there are 6 work items. And it doesn't matter for our bot whether it is 6 work items or 600 work items. The only limit that we have in this scenario is the context token limit on GPT side. And in my previous videos about GPT, we already learned that there are different GPT models with different context token limit size. So it is a question of selecting the proper GPT model and applying GPT best practices about working with context that we also learned in previous lessons. Let me open Jira board in order to make sure that bot provided me with correct response. Of course, when I work with my team on production data, I don't check it each time I receive response from the bot. But right now, let's perform some checks, just for the sake of the demo. And as you can see on our Jira board, we have also 6 work items. So all is good, and bot's response was correct. Let's ask some other questions. For example, GPT, how many work items Andrei Petaha has assigned now? And we receive response that Andrei Petaha currently has 3 work items assigned in Jira. And we can open Jira board one more time just to check and make sure that our bot doesn't lie us. And we can see that Andrei Petaha has only 3 work items assigned. Cool. Let's ask the next question. GPT, how many work items with the type bug we have now in not completed status? And it replies us that we have just 2 bugs. I will not check each response in order to have enough time to show you more examples. I already showed you our board, and you can trust me that these responses are correct. Or just go back and check board one more time. And at the meantime, let's continue and ask the next question. GPT, can you group these bugs by status, please? And we received breakdown of our bugs by their statuses. One defect is in to-do status, one is in progress status, and one bug is in done status. And we can continue conversation in this chat with our team members. And the coolest thing about this is that I don't use any GQL. I mean Jira query language. I use conversational language like I would ask any Scrum Master or QA in my team to get more information before I continue with the conversation. Okay, let's continue. Let's ask the next question. GPT, check please due dates of not completed bugs that you referred to and tell me when is the latest due date. And we can see that the latest due date among not completed bugs is August 4th, which is logically correct. And we again received information that we needed. The next question sounds like this. GPT, and who is the bug with the latest due date assigned to? And we can see that the bug is assigned to Andrei Petaha. Usually in responses you can receive different volume of information. It depends on the GPT configurations that we already learned. This example just shows you that you can check some basic information about items that was mentioned previously in the context. You can ask some more interesting questions, like for example the following one. GPT, can you remind me of the issue ID please, in the scope of which we planned to implement a persistent card state across multiple browsers for the same account? When I deal with hundreds and sometimes with thousands of tickets on the big programs that I manage, sometimes it is hard to remember specific work item ID of the task that I'm interested in. But still, I might need the reference to the ticket in order to check the latest status, comments, check assignee, etc. And I can ask GPT to help me with this task, like you saw in the demo. Now I can get navigated to the work item with ID LIT-4 and check information that I need. In this particular case, GPT analyzed the description field in order to find the ID of the task that I am interested in. You can see that in this case, the summary of the task doesn't provide us with a lot of details and useful information. But in the description I see that this task is about implementation of card component, ensuring that the state of the card persists in different tabs and in different browsers for the same account. Basically, you can ask any other questions that you may think of, like for example, GPT, can you group all items from Jira by assignee please? And you will be provided with a breakdown by assignee. Please note that we have one work item on the dashboard that is not assigned to anyone. This is done for testing purposes. Of course, in real life you would avoid cases like this. But we can see that in total GPT provided us with details about 5 tickets, because the 6th ticket doesn't have assignee. GPT, can you group all items by issue type, please? Almost the similar kind of task, but in this case we group by issue type. and we again receive correct response. These are just few questions that I use or my Scrum Masters use when managing the teamwork and during the collaboration. Of course, if you are an experienced project delivery manager or delivery director, you can imagine the whole potential power and set of use cases how you can apply this bot to boost collaboration within the team to the next level. So, I am done with the demo and with review. Now it is time to understand how all this is implemented. And I open my IDE to walk you through the source code. As always, you can find the reference to the solution in attachments to this video. I am going to make an overview of how I implemented the application in order to achieve the end result that I have just demoed. And in case you would have any questions, you are always welcome to post your questions below the video and I will be happy to answer. So, this is the application that I developed from scratch during the previous lessons and shared with you each line. That's why today I wouldn't stop too much on the pieces of code and configurations that we already reviewed in the previous lessons, and I will focus your attention only on things that were changed here. I open Slack Integration Controller class. Here we got notified about the Slack events we are subscribed for. So far, we are subscribed only for the one event, that is application mentioning event. We receive it here, and we call process on mention event of the Slack service. Nothing is changed here. Let me then go to the default Slack service. I opened the default Slack service class. Here I introduced improvement. When I call getAnswer to single query method, I pass an array of GPT functions. You can see that functions variable refers to a list that I let Spring to initialize by putting autovariate annotation. Like this, Spring gathered all beans of GPT function type discovered within the context. And taking into account getAnswer to single query takes variable argument of GPT function type, I need to convert the list to array. Because as you know, in Java, variable argument type may be treated as an array within the method. Currently, in this list we have two functions. One function is from the lesson when we learned function calling feature in GPT. Do you remember we had GPT weather function that's supposed to return us the weather in the specific location? That was an easy example. I decided not to remove it from the source code because this is the learning project and I want to store this example in the repository for future students. And the second function is the main one for today's lesson. In the beans configuration class at the bottom, you can see that I declared GPT Jira issues function. Let's understand what it is. Just in case you skipped function calling lesson, please come back and watch that lesson, because understanding function calling in GPT is the key for understanding of this implementation. So, function should have name and description. I decided to store this information in properties file. I open my app properties file. The function name is simple, get Jira issues function. The most important is the description of the function, because based on the description analysis, GPT will make a decision whether it makes sense to call this function or not. Based on the description, you can understand that I have a function with such name that can return all Jira issues of all issue types from the configured Jira project in order to provide information about team members' workload, current plan, due dates, issue descriptions, summaries, total amount of issues, find the issues of the specific type, find the ID of the issue by its summary or description, calculate team workload, and lots more. Few comments here. Definitely this is learning course, but we learn the principles that may be applied on production scale. For example, in my production application, I have multiple functions created. There might be cases when you need the whole amount of Jira tickets, but there is also might be need to fetch child items of some epic, or items that contains only specific label, and we don't need the rest of the items. It will help you to optimize performance and costs spent on GPT. Just an idea to think about. In scope of this lesson, we are going to review implementation of this function, because all other functions can be implemented exactly in the similar way. The second thing here, it is set for configured project. There are different ways of how you can configure project. It all depends on the business requirements and how you want to build interaction with the end user. For example, you can ask end user to provide all necessary configuration during the interaction with the bot. Or you can make this configuration as mandatory one during the bot installation, or any other option. In our particular case, I configured the project key in the properties. A little bit later in this lesson, I am going to show you where it will be needed and where we are going to use it. So, coming back to Beans configuration class, I used value annotation to inject values from the properties file. Then I set name and description values into GPT function object. Then, important point, GPT should identify input arguments for our function. And we need to tell GPT what type of arguments with what name we need. But in this specific case, we don't need any input arguments, because we don't need to filter result or sort result or any other input arguments to work with. We just need to fetch all work items from Jira project, that's it. But still, according to GPT API, parameters attribute is required. And in documentation it is said that in case I need to describe a function that accepts no parameters, we need to provide the value object for type property of the parameters object and empty object value for properties attribute. Taking into account that JSON library doesn't take into consideration fields with null values during the conversion from object to JSON format by default, we need to come up with some workaround in order to meet the requirements of GPT API. So, I set object type for parameters object. I did it according to documentation. And for properties, I created an object of type noProperties that basically doesn't have any state. It is compatible with our marker interface parameter properties. So I can set properties now, set parameters to the function, and function is ready. What happens next? I open default GPT service class. Inside the getAnswerToSingleQuery method, I call prepareRequest method where I add functions to the GPT request object. Now we are ready to send the request to GPT. Request is sent inside the method getResponse from GPT. Here we have method extract GPT response content. I don't stop on the detailed review of these methods because nothing was changed. If you forgot the implementation, please check previous lessons. The only thing that was changed here is the part related to the function call. Let's review it again from the top. So in case in the GPT response there is a request for function call, we enter this if block. I get the reference to the function bin using the function name. I implemented here factory method pattern. I just did small improvements in the function factory class. Let me show it quickly. I implemented application context aware interface. This is done on purpose in order to use the existing context instead of creating the new one. I just need to implement setApplicationContext method and initialize application context field. All necessary injections will be done by Spring. This is done in order I can extract the bin from the current application context. Because my getJiraIssues function bin contains injections from the properties files and depends on the Jira service bin. So this improvement in the function factory is exactly what we need to do in order to make this solution work as expected. If you want to learn more how it is implemented, we reviewed it in the previous lesson when we learned function calling feature. Once I received the reference to the function, I call execute method. In the bin's configuration file, you can find the bin with name getJiraIssues function. Let's review it and understand how it works. I injected Jira service and XON into this class. In execute method, I use Jira service to extract all Jira issues. I need to make a review of multiple types here: Jira service, default Jira service, and Jira issue. So let's go one by one. Jira service. Let me start an overview from Jira service interface. So this is a high-level interface that defines the contract for two methods for now. The first method is getFullJSON issue by ID. It appears here as part of the refactoring after lessons about Jira API. I moved the code from the controller to the service, and now we can use Jira service bin to extract the JSON of any work item by its ID. And in Jira integration controller class, you can see that getIssueById method was refactored too. Now I delegate the call to the Jira service, and the code that was here in the previous lesson was moved to the default Jira service. I also did some minor cosmetic changes in the URL and query parameter name. In attachments, you can find the reference to the commit with all changes, and you can investigate it. And remember that in case of any questions, please do not hesitate to post your questions below the video, and I will be happy to answer. Also, for demo and development purposes, I created here endpoint that allows you to fetch all issues from Jira without posting message to Slack. You can do it by directly accessing this resource. And here you can see that getJiraIssues method is also invoked. The same method is invoked in the getJiraIssues function. So, let me open now the default Jira service class and review it together with you. Let's start review from the getJiraIssues method. The first thing that I do in this method, I build a URL. The URL consists from the Jira API base URL, search resource URL, and query parameter with name GQL. GQL stands for Jira Query Language. So I can pass GQL here to fetch issues that I need. I pass here project name and max results. I have few comments here. First of all these field values are initialized with values from the MyAppProperties file. Let's check it. I open MyAppProperties file. I changed the version of Jira API to the second one. We reviewed Jira API versions in the separate lesson, and I said that Jira API version 2 is the most stable one based on today. And also, it provides the content of description field as one single value, which is easier to parse. In the Jira API version 3, the content of description field is divided into blocks. It is also available to parse it. But I don't like complicated things when there is an easier option available. So I decided to change it to version 2. Then you can find here issue resource and search resource, and Jira project name too. That is our project key. Probably you might be wondering, where to get project key? Let me show it to you. Basically, you can easily find it in each work item ID. Each ID consists from the short abbreviation, dash, and number. Like you can see here, LIT-4, or here, LIT-5. To change the project key or just to find it, you can go to the project settings. So, click on the project settings in the left pane. And here in details section, you can check the key field. So, just copy it and paste it in your web app configuration. Max results property is also configured in the MyAppProperties, and as you can see it is equal to 100. Because according to the documentation, it is max amount of items allowed to return within one single query. But what to do in case there is more than 100 work items in the backlog? Jira API implements pagination approach. Basically, in each response, you receive information about the total amount of records available in scope of the current request. For example, you receive 100 value in the max results attribute. That means that you can count on reading 100 records from the current request. Also, in each request, you will receive the total field. This field contains information about total amount of records that match your query. And you also receive start at attribute that tells you from which record the list is started. Usually it is 0 here, but during the request you can specify start at attribute and thus receive the next 100 tickets. But be attentive with numbers, because indexing is started not from 1 but from 0. And your homework would be to implement just enough code to handle pagination of Jira API. Write it down, it would be a nice practice for you. So basically, you would need to call Jira API multiple times in case total amount of records is higher than value in max results attribute that actually specifies the amount of records returned. Okay, so it looks like we're done with building the query. Then I create HTTP GET request. In this example, I use Orc Apache HTTP client library, but you're welcome to use any library you wish. Everything what happens next is parsing the returned JSON, and namely array with issues. But pay attention that I don't send to GPT the whole array of issues. Why? Because of multiple reasons. First of all, cost optimization. I don't want to give redundant content that will not help me to find the answer on my questions. So, it is up to you to hold the business analysis and define what fields of Jira issues do you really need that would make impact and will help to provide the end user with the answer to the question. The second reason, we need to remember about GPT model token limit. I just try to not send redundant tokens, and instead I would prefer to leave some space for useful information that I can send to GPT. The third reason, I care about performance. Again, I don't want to ask GPT to analyze more data than actually needed. Thus, we win some time during the data processing. The fourth reason, I follow clean architecture principles in the OOP design. The idea that I follow here is to have business-oriented entities. Namely, in case API will change, I don't need to refactor the rest of the code in the application, because the rest of my code depends on the business entity Jira issue, and in case API will change in the next versions, I would need to adjust only this method in order to parse all required information and data properly, and the rest of the code will keep using the Jira issue programming interface. To understand my answer better, you need just explore the details of each Jira issue and understand how it looks like in the API. In the lessons about Jira API, we already saw an example of extracting issue by key. As you can see, while parsing the JSON here, I set the values into Jira issue objects properties. Jira issue is my business entity that contains only that information that is needed according to my business requirements. Let's review the source code of this type. So, Jira issue contains such information: key, assignee, description, summary, status, due date, project key it belongs to, project ID, project name, priority, issue type. And just to let you know that I also made some changes in my Jira and extended standard set of fields with such fields as priority. How to add new fields to Jira you can learn in the Jira section of this course. Taking into account we already discussed this in the previous lesson, I wouldn't stop on this too much. Everything else in this class is just getters and setters, so nothing special. Let's get back to the default Jira service. So I iterated over each issue in JSON. I converted it to the Jira issue and added those to the list. The list of Jira issues is returned from this method. The second method is the one that we already reviewed in the previous lesson. As I already mentioned, I refactored code a bit and moved this code from the Jira integration controller to the default Jira service. Now you know how getJiraIssues function works. Once Jira service returns the list of Jira issues, I just need to convert it to the JSON, because we would need to send this list back to the GPT in order it could prepare an answer for us based on the whole required data gathered. Let's get back to the default GPT service. So, function got executed and we received the JSON response of this function. Amazing. What happens next? Then I do the same thing that we already learned in the function calling lesson. I create GPT message because right now I need to add one more message to the context and then send it back to the GPT. The message should have function role. In GPT API, there is a dedicated role reserved for the function responses. Another interesting method that I implement here is called addMessageWithTokenLimit. Imagine the case when you have a lot of messages already in the context, and you fetched 100 Jira items, for example, or 200. The main thing is that response that you received and wanna add to the context will go over the tokens limit defined by the GPT model selected. Understood? For example, imagine that your model selected supports 4,000 tokens. Just an example. And you are going to add a response after function call that is 3,000 tokens long. But you also already have more than 2,000 tokens in the context. What to do in this case? In order to not catch the exception, it is better to remove all these messages from the context and put response after the function call into the context. Agree? That's the purpose of this method. In this method, I check whether the total length of the context together with the length of the new message that I wanna add will stay within the limits. If no, then I remove from the context the element at 0 index position. That would be the oldest message in our Slack conversation. And then I call this method again until we would be able to add the message. Taking into account we have recursion here in this method, it is super important to define the conditions of breaking the recursion. So, in case there are no messages left in the context, that means the size of the list with context messages is equal to 0. Then I return from the method. Then I set functions to null in order to optimize the costs by saving some more tokens on functions description. And then I have another important point. In case there is 0 messages left in the context, I will not send request to the GPT. Instead, I would just return error message that tells end user to contact with the administrator because the current GPT model selected ran out of tokens limit for this request and request can't be processed. Definitely, you can implement other logic to handle situations like this. When this case may happen, imagine the case that the length of the function call response from Jira would be 20,000 tokens. Well, for example, it will depend on how you implemented your solution and how big your Jira project is, but your model can handle only 4,000 tokens. Then, our previous method that we have just reviewed will not add anything after removing all the context messages. And in case we removed all messages from the context trying to add the response from the function call, there is no sense to send request to GPT because we already removed original request and our response after function call may also not fit within the context limits. These are limitations that we need to accept. So, what I would recommend you to do in this case? If you follow the lesson attentively, you might already hear the answer. In the production version of this application that I use with my team to manage our work and to collaborate, I have multiple functions defined that return not all Jira work items, but return only those items that meet criteria. Basically, the GQL query to filter on the requested issue is created, and I don't need to overwhelm the context with data that is not required to answer my question. For example, if I request information about bugs, there is no need to fetch epics, stories, tasks. If I ask question about child items of the specific epic, I don't need to provide GPT with the other tickets that are not related to the specific epic from the conversation history. Do you understand my point? Anyway, in case something is not clear, please let me know about your questions in comments below this video and I will be happy to answer. In our code, we send request to the GPT and receive response, and return this response to the end user. That's how it works, and we already hold the demo, so I believe you can imagine end-to-end scenario. Let's recap what we have learned in this lesson. In this lesson, we learned how to integrate Jira, GPT, Slack, and our web application. We implement function calling feature in our application. I hold an end-to-end demo of web applications that's supposed to boost the collaboration within your team. We reviewed architecture of our application and discussed best practices of web application development and saw how to apply them on practice. That's all what I wanted to share with you in this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.